Hey, Honors Chem, Mr. Lambert here. This is the last video that I'll be posting for Chapter 7. It is Section 7.6, Calculating Molecular Formulas. Hopefully, if you watched the last video, which was focused on calculating empirical formulas, we'll be able to use that knowledge to calculate an actual molecular formula. If you notice, I put in the top left corner, I'm on page 215 in the textbook, question 7.56. The question, I sort of condensed it a little bit, but it talks about lactic acid. It's an actual chemical. That's the burn that you feel when you exercise. It's an acid that builds up in your muscles when they're not getting enough oxygen quickly enough. And it talks about the composition of lactic acid, just like an empirical formula problem. 40.0% carbon, 6.71% hydrogen, and 53.3% oxygen. Here's the difference with molecular formulas compared to empirical. It tells us that the experimental molar mass in some sort of laboratory experiment tells us that actual lactic acid has a molar mass of 90. I thought that was cute. They actually put the decimal in the textbook, 2 sig figs, 90 grams. Okay. And the question is, what's the molecular formula? Well, in order to determine the molecular formula, we first have to determine the empirical formula, just like we've been doing recently. So I'm going to pause the video and I'm going to set up the solution to find the empirical formula of this particular chemical. Again, 3 elements, carbon, hydrogen, oxygen. These percentages add up to 100%. So we're going to assume that we have 100 grams of the chemical, and I'm going to be going from grams of each of these elements into moles, setting myself up or getting a ratio, and we will come up with an empirical formula. Okay, I've done the setup, and hopefully you can all see it. We have, again, we're dealing with lactic acid, and we're trying to find the empirical formula. We have 40.0 grams of carbon, 6.71 grams of hydrogen, 53.3 grams of oxygen. Notice I'm dividing by the molar mass of each of these, and I have come up with the answer. I've rounded, of course, to the correct number of sig figs. 3.33 moles of carbon for every 6.66 moles of hydrogen to 3.33 moles of oxygen. I first want to have you focus on this area right here. Maybe you can eyeball it. Again, in the last video, I talked about dividing by the smallest number to get the smallest whole number ratio to find the empirical formula. The cool part about this problem, which is why I wanted to show it to you, is that both carbon and oxygen are the smallest number. So we're simply going to divide everything by 3.33 to get ourselves a ratio. If I divide the top by 3.33, that of course is going to be 1. And I'm going to circle that. Same thing here, divide by 3.33. I can't write this way. And that's also going to be 1. As most of you probably already saw, 6.66 is going to be twice what 3.33 is. So I'm going to divide by 3.33, and that's going to come out to 2. We have just found our empirical formula, not necessarily the molecular formula for lactic acid, but the empirical. If we give the formula in the way that the elements were given to us, we'll come up with an empirical formula. You can all see this still. CH2O. Now that's great. That's just our empirical formula. But if you remember from the beginning of this video, it said that lactic acid has an experimental value, experimental molar mass, of 90 grams. What you now need to do to calculate a molecular formula is compare the molar mass of your empirical to the molecular. So I'm going to pause the video once again, and I'm going to show you the molar mass of CH2O and see how that compares to 90 grams. Okay, I didn't show myself adding it up because we should know how to calculate molar mass, and I'm trying to make the video as brief as possible. If I take CH2O and I add up 1 carbon plus 2 hydrogens plus 1 oxygen from the periodic table, and I find the molar mass of our empirical formula, it comes out to 30 grams per mole. Well, how does that relate to 90 grams per mole? We simply need to realize that the molecular formula is going to be some sort of multiple of the empirical formula. And so what we do is we take this number that we were given at the beginning of the problem, which we don't use till now. We're going to take 90 grams, we're going to divide by 30. Of course, 90 with a decimal divided by 30 with a decimal. I'll put grams on there. The answer is 3. Lactic acid's molecular formula is 3 times heavier than the empirical formula's molar mass. So we're simply going to take our empirical formula that we calculated, CH2O, and multiply by 3. All of the subscripts are going to be multiplied by 3. Again, you know that there's no subscript here, so that's the ratio is a 1 to 2 to 1. We're going to multiply everything by 3. Lactic acid's empirical formula is CH2O. Its molecular formula is C3H6O3. And that is how you find molecular formulas from an empirical formula.